So that at least gives you the idea of how we can take advantage of the buffer overflow and say hello and end up running a program that is not even mentioned in the source program at all. We're not relying on get_shell_path being super helpful here. We are relying on this helpful debugging information that told us where the buffer is located in memory. And of course, in realistic situations, you don't get that information directly. But you can imagine that it's just a matter of finding more gadgets that take the stack pointer, move it into a register, and adjust it by a certain amount that you know that will always be the same offset from the stack pointer into the buffer. Finding those gadgets can be tricky. So it's too hard to find those gadgets by hand. I managed just by looking at fgetS, just enough to run bash without address space randomization. You would have to find some more gadgets to build up a stack relative pointer. There are tools that can do this. It can look through the C library, look at all the machine code, figure out what gadgets are there, and even generate a compiler that knows how to string those gadgets together to do something higher level than manually working out the machine code. It turns out that x86 helps us out by having instructions that are of various length. We need to find return instructions, and it turns out the encoding of return instruction is a C3, but sometimes a C3 can appear in the middle of an instruction. Just to demonstrate, we can go back into LLDB, and I'll stop at main. If I disassemble, say, the sign function, and if I do that, printing out its bytes along the way, then one thing you can see right away here is there's a C3 sitting there. It's in the middle of this mol SD instruction, but if it happens that these bytes before mean something else, we can actually jump into the middle of an instruction, not just the middle of a function. That's a bonus that you don't get on most instruction sets where instructions are aligned, but you do get it with x86. Finally, you can use a mixture of techniques. You can find enough gadgets that let you eventually call mprotect on some region of memory that you are able to write some machine code to, say onto the stack. So there's a lot of things you can do with this return-oriented programming based on gadgets, and it can be used as a bootstrapping mechanism to get into some more general and simpler way of attacking the system.